Hello, tech enthusiasts! Preparing for a data science interview can feel overwhelming. There's statistics, machine learning, data cleaning, SQL, Python, and the list goes on. But here's the good news. Most interviews revolve around a core set of practical questions, not extreme theory, not beginner basics, but real, medium-level questions interviewers love to ask. In this video, I'll walk you through 15 medium complexity data science interview questions with clear explanations, so you not only know the answer, but also understand why. Let's get started. Question 1. What is the difference between supervised and unsupervised learning? Supervised learning uses labeled data, meaning the target outcome is already known. Examples include regression and classification problems. Unsupervised learning works with unlabeled data, where the goal is to discover hidden patterns, like clustering customers or reducing dimensions. Interviewers ask this to check if you understand how learning problems are framed. Question 2. What is bias and variance in machine learning? Bias refers to errors caused by overly simple models that underfit the data. Variance refers to errors caused by overly complex models that overfit the data. A good model finds the right balance between bias and variance, called the bias-variance trade-off. Question 3. What is overfitting, and how do you prevent it? Overfitting happens when a model performs very well on training data but poorly on unseen data. Common prevention techniques include cross-validation, regularization, pruning, using more training data, simplifying the model. Question 4. Explain the difference between classification and regression. Classification predicts categorical outcomes, like spam or not spam. Regression predicts continuous values, like house prices or temperature. The key difference lies in the type of output the model produces. Question 5. What is feature engineering, and why is it important? Feature engineering is the process of creating, transforming, or selecting features to improve model performance. Good features often matter more than complex algorithms. This question checks real-world data science skills, not just theory. Question 6. What is normalization and standardization? Normalization scales values between 0 and 1. Standardization scales data to have a mean of 0 and a standard deviation of 1. These techniques are important for distance-based algorithms like k-means and SVM. Question 7. What is a confusion matrix? A confusion matrix evaluates classification models by showing true positives, true negatives, false positives, false negatives. It helps calculate metrics like accuracy, precision, recall, and F1 score. Question 8. What is precision versus recall? Precision measures how many predicted positives are actually correct. Recall measures how many actual positives were correctly identified. Precision matters when false positives are costly. Recall matters when missing positives is risky. Question 9. What is the F1 score? The F1 score is the harmonic mean of precision and recall. It's useful when dealing with imbalanced datasets, where accuracy alone can be misleading. Question 10. What is cross-validation? Cross-validation splits data into multiple folds and trains the model multiple times. This ensures the model performs consistently and reduces dependency on a single train test split. Question 11. What is dimensionality reduction? Dimensionality reduction reduces the number of features while preserving important information. Techniques like PCA help improve performance, reduce overfitting, and make models faster. Question 12. What is PCA in simple terms? Principal component analysis transforms correlated features into a smaller set of uncorrelated components. These components capture the maximum variance in the data. Question 13. How do you handle missing data? Missing data can be handled by removing rows or columns, imputing mean, median, or mode, using predictive models, forward or backward filling. The approach depends on data size and business context. Question 14. What is the difference between SQL joins and when do you use them? Inner join returns matching records. Left join returns all records from the left table. Right join returns all records from the right table. Full join returns all records from both tables. Data scientists use joins to combine data from multiple sources. Question 15. How do you explain a complex model to non-technical stakeholders? I focus on business impact, visual explanations, simple analogies, key drivers, not equations. This question checks communication skills, critical for data scientists. If you found these questions helpful, hit the like button and subscribe to Skills on Cloud. In the next video, I'll cover advanced data science interview questions, including real-world case scenarios. Alea, daiwansere. I trulia. Alea. Until then, keep learning, keep practicing, and I'll see you in the next one.